Hi future doctors, welcome to the next class. In this class we'll see about refraction. Till now we discussed about reflection. Now what is meant by refraction? Here refraction is nothing but simply bending property of light. Bending property of light is called refraction. But when this will occur means when light is traveling from one medium to another medium. So what is this one medium to another medium? So what are those medium names? All these we are going to see. So this will be coming like basics also. So when light is going to be bending, so if you observe, so normally, so rather than this physics, normally whenever you are crying, whenever in your eyes water is there, you cannot see any object properly, you cannot read properly, isn't it? So like that, if you see any objects behind the flame, if fire is going to be, other side of the objects will be oscillating, isn't it? Like that, whenever you are placing any object inside the water, so 5 rupees coin is dropped means it seems to be it is available here if you are observing from here. So let us assume if you are taking a stick and it is going to be immersed, it will be bending inside. So if you are taking it out, how much you are taking out? Inside one will be like bending. Actually stick will not bend. So light ray is going to bend, like therefore you will be seeing object like this within the water. So why this bending property is coming means normally if you are going on a bike or bicycle on a road, suddenly sand came. So what will happen means it is going to skid, it is going to drag, isn't it? Its path is going to be changed. Suddenly came so much water. So again its path is going to be changed. So whenever medium is changing, road to sand, here also air to water, air to glass. So its path is also going to be changed. So for that, first we should come to know the term refractive index of this medium. What is refractive index? In some books they will represent mu, in some books they will represent n. So what is the refractive index of medium means? Velocity of light in vacuum by, so velocity of light in that medium. So V is equal to C by N or C by mu. What is mu here? Refractive index. So velocity of the light is going to be changed in the medium. So for refractive index of air, they will say generally 1. So refractive index of glass, refractive index of water. So glass they will take 3 by 2. So water they will take 4 by 3. So 3 by 2 means 1.5. So 4 by 3 means 1.33 they are going to take. So generally refractive index of glass, refractive index of water, they will take like this. Now what is the velocity of light in glass? What is the velocity of light in glass means? So velocity of light in vacuum by refractive index of glass. So velocity of light in vacuum 3 into 10 power 8. What is the refractive index of glass? We said 3 by 2. So 3 by 2 if you take 3 will be cancelled, 2 is going to be numerator. 2 into 10 power 8 meter per second. So what is the velocity of light in water? Velocity of light in water is C by refractive index of water. That is going to be 3 into 10 power 8 by 4 by 3. So you will be getting 9 by 4 into 10 power 8 meter per second. 9 by 4 means 2.24 are 8. 2.25 2.5 into 10 power 8 meter per second. So this is about velocity of light in glass, velocity of light in water, and velocity of light in air. 3 into 10 power 8. So if light is traveling from air to glass, air to water, air to or glass to water, so medium is going to be changed. Now which medium is called, how we are calling means one medium to another medium, where velocity of light is more, where velocity of light is more, that medium we will call rarer medium. Where velocity of light is less, that is called denser medium. So whenever light is traveling from one medium to another medium means rarer to denser. How you will say rarer and denser means depending on its velocity of light. Air to glass. In air, 3 into 10 power 8. In glass, 2 into 10 power 8. So which is more? Air is more. Therefore, air is called rarer medium. Glass is called denser medium. So always glass is not denser. Depending on the medium, it is going to be changed. Air to water. In air, 3 into. In water, 2.5. Isn't it? Correct? Nearly only 2.5. 2.5 or 2.25 this is 2.25. Correct? So, however, it is glass to water. In glass, what is the velocity? 2 into. So, in water, 2.25. Where it is more? In water, it is going to be more. Therefore, water is, for this case, water is rarer medium, glass is denser medium. So, where velocity of light is more, that is rarer medium. So, where velocity of light is less, that is denser medium. Blindly you can remember, isn't it? So, now we got rarer medium, denser medium. Now it is bending. How it is going to be bending? So, whenever it is moving from rarer medium to denser medium, rarer medium to denser medium, this is going to be incident ray, angle of incidence. Let us assume if it is reflecting, angle of incidence should be equal to angle of reflection. This is reflection. But whenever it is going to denser medium, actually it should go like this. But because medium is changing, it is going to be bending towards the normal. This is called angle of refraction. Why it is bending towards the normal? Because velocity is changing and velocity is going to be in rarer medium it is more, here it is less, therefore it is bending towards the normal. So R is going to be angle of refraction. So this angle delta is called angle of deviation. How you will get the delta means angle between incident ray and normal is I, and this original ray dotted line, and this one is also going to be I. So delta is going to be I minus R. This is angle of deviation when light travels from rarer to denser. If light is moving from denser to rarer, so this is the normal. This is angle of incidence with normal always. So light is bending. Actually, it should go like this. It is moving from denser to rarer. So in rarer, velocity of light is more. Therefore, it will bend away from the normal. So this is I means. So this is also going to be I. So this is going to be angle of refraction. Then what is angle of deviation? So R minus I. Correct? Angle of deviation is going to be R minus I. Whenever light ray is moving from rarer to denser, it is I minus R. Denser to rarer, it is R minus I. Angle of deviation. R is nothing but angle of refraction, not angle of reflection. Reflection means it is coming to the same medium, isn't it? Next, loss of refraction. So, loss of reflection we came to know. Angle of incidence, angle of reflection will be same. So, incident ray, normal, reflected ray will be in the same plane. This is also same. Incident ray, normal, refracted ray. So, these three will be in same plane. Incident ray, normal, refracted ray. These three will be in same plane. That is XY plane. And second law, that is going to be Snell's law, they are going to say. So, what is that Snell's law? How we are going to apply? So, we will see in our next class. So, you might have observed why this stick is going to be bending towards the normal means here light ray is bending towards the normal, therefore stick is bending like this within the water. So you might have seen this one in 8th class, 9th class, some diagrams. Stick inside is going to be bending. So this is because of bending property of light. Okay. So Snell's law. So how to apply Snell's law, we will see in our next class. Thank you.